Hi, fifth grade. Today we're going to be doing Module 4, Lesson 30. So we're jumping all the way to the end of the book right now. And we're going to be doing dividing decimals right now. So for dividing decimals, what we are going to do is almost exactly what we did for multiplying decimals. So it's going to be extremely similar to that. So I think today's lesson should go really, really well. So for problem 1A on your sheet, we are actually going to do the same process that we did before, where we're going to change our decimals into fractions and then do our math operations from there. So, for example, for this problem right here, we have 2 wholes divided by 1/10. So my 2 wholes are going to stay the same because I can't really rewrite 2 wholes as a fraction. I guess I could just have 2/1 if I really wanted. But I do have to rewrite 1/10 because it is a decimal. So 1/10 I can write as 1/10. Now, this problem looks almost exactly like something what if you were to be doing those dividing fractions lessons from a little bit earlier ago. And all I need to do is I need to just rewrite this 2, change my division symbol to a multiplication symbol, and then I need to find the reciprocal or the flip-flop of 1/10. So 1/10 will flip-flop over to 10/1. Remember, I could also think of that 2 as 2/1 if it helps me out. And then after that, I can multiply. So as you can see, all of our steps so far have been almost exactly the same as the steps we would use to multiply decimals. It's just using those rules that we know for dividing fractions to help me out with that next part. So now we have 2 times 10, which gives me 20. And then 1 times 1, which is 1. But since it's a whole number, I'm just going to leave it alone. So and I don't really need that 1 underneath it because it's just showing me that 20 divided by 1 equals 20. And that is my final answer. So 2 divided into tenths equals 20. So we take the fractions, make them into take the decimals, make them into fractions. Then we use our dividing tricks that we've learned. So we change our division symbol to multiplication, flip-flop, or find the reciprocal of our fraction, and then multiply to get our final answer. So let's try it again with this problem over here. So now we have 2 being divided into 2/10. So again, I'm going to leave that 2 the same. My division symbol, I'm going to leave it the same just for now because what I want to do is I want to rewrite this expression right here as a fraction. So I want my 2/10 to be fractions. So that would be 2/10. And now I can rewrite my problem using that multiplication symbol. So my 2 will stay the same. Remember, that first number never changes. My division symbol becomes a multiplication symbol, and then my 2/10, we're going to find the reciprocal of that, or the flip-flop. So my 10 will go onto the top, and my 2 will go onto the bottom. And then I can multiply. Remember, if it helps you, there's that invisible number 1 underneath all of your whole numbers. So we're not going to take this 2 and multiply it by the 2 on the bottom and create our denominator. This 2 only goes straight across and gets multiplied by the other numerator. So we do 2 times 10, which equals 20. And then we can think of this as 1 times 2, which gives me 2. Now, what this leaves me with is an improper fraction, which I don't like. So I have 20 divided by 2 left over. And yes, normally you can just do a standard algorithm to find your mixed number. But if you can figure out the answer, then you can just write that. So we have 20 divided by 2, which gives me 10. And 10 is our final answer for this problem. So, and what you'll probably notice is what's different about the answers that we're getting right now is that most of our answers from the dividing or multiplying decimals lessons, we had to change our answers back into decimals. But with these, since we're getting whole numbers, we don't have to do that. There may be some problems where you have to do that, but for the most part, you're not going to have to worry about it. So let's take a look at 1C and D now. So for 1C and D, again, we'll just rewrite the expression. So we have 2 4/10 divided by 2 tenths. Since this whole expression is in decimal form right now, I want to just first rewrite it using fractions. So if I have 2 and 4 tenths, I'm going to look at this number and think about what does it look like without the decimal point. So that looks like 24. So that's going to be my numerator. And then my denominator is going to be whatever is my last place value. So if I have 4 and this 4 is in my tenths place, then 10 will be my denominator. Then remember, we're still dividing. I don't want to change this to a multiplication symbol just yet. And then after that, I have 2 tenths. So this 2 is going to be my numerator, and since my last place value is the tenths, then I'll write that number just like this. And then we can do changing this into a multiplication symbol and getting the reciprocal of 2 tenths. So we'll keep 24 tenths, change our division symbol to a multiplication symbol, and then 2 tenths will flip over to become 10 halves. Now I need to multiply going straight across, and you might look at this and say, oh my gosh, this is so hard to multiply, but trust me, it's not, because we can just do 24 times 10, and this is a problem we should be able to do in our heads, because we can do 24 times 1, I know that's 24, and then if we just do add that 0, then we get 240 all over 10 times 2, and 10 times 2 we know is 20. What I'm left with now is 240 over 20, and again, you might think this is difficult, but I can cross off my zeros, so I have 1 0 on top and 1 0 on bottom. So I'm going to cross off both of those zeros, and then I just have 24 divided by 2 left over, and I know that that just equals 12. So our final answer for this one is 2 and 4 tenths divided into 2 tenths would give me 12. And basically what this is saying is that if I had 2 and 4 tenths and I divide it into these little like 2/10 pieces, I would have 12 of those pieces. So that's why our answers have been whole numbers so far. And I totally understand that if you get to this part and you can't do the division in your heads, you can always do a standard algorithm to help you out. I'm just telling you that if you don't want to do the standard algorithm, you can try to do some of this math mentally. So let's take a look at D now. So this was C over here. Let's take a look at D. For D, we now have 2 and 4 tenths still, but we're dividing it by 4 tenths. So for this problem, we first need to change all of our decimals into fractions. So I take a look at this, and it looks like 24, and my last place value is still 10. Then I need to still write that division symbol. We're not changing that just yet. And I have to write 4 tenths. And now I can do the first step of my dividing fractions. So 24 tenths will not change. Remember, our first number never changes. The division symbol will become a multiplication symbol. And then 4 tenths, we need to find the reciprocal or the flip-flop of that. So 10 will go on top and 4 will go on the bottom. And as you'll see, this problem and this problem are very similar in this step. So we already know that 24 times 10 is 240. And I already know that 10 times 4 is 40. So what I need to do now is I can do the math just like I did right here. So I see I have 1 0 on top and 1 on the bottom, so I can just cross those off. And then we can do 24 divided by 4. I know that 24 divided by 4 equals 6. So 6 would be our final answer. But remember, if you want to do the standard algorithm, you can always do the standard algorithm. Like I know that 40 can fit into 246 times, and then I would just have to do that multiplication step to check that work, and then I would get my final answer of 6. So 5th grade, we are going to move on to 2A and B now, and now we're going to be moving into the hundredths place, so our answers might look a little bit different. So for 2A, we have 1 6 tenths divided by 400ths. And I want you to stop and think right now, what is my answer going to look like? Am I going to have a bigger whole number, a smaller whole number? What do you think is going to happen with our values? So what I first need to do, always my first step, is changing these decimals into fractions first. So I look at this decimal right here, it's 1 6/10. So I am going to take a look at that without the decimal and think about, what does this number look like? To me, it looks like 16 over, and I'll look at my very last place value. My very last place value is the 10th place. So I'll write a 10 underneath this. My division symbol is going to become a multiplication symbol. And then 400ths, if I look at it without the zeros and the decimal, it just looks like that number 4. And then it's going to be all over 100, since that is the last place value. Oops, I should not have changed that just yet. Remember, we're still just changing these into fractions, and now I can start that first step of division. So 16/10ths will not change. Now my division symbol will become a multiplication symbol, and then after that we're going to flip-flop for 100ths so that I have 100 over 4. Then I can start multiplying. So we have 16 times 100, which equals 1,600, because I have 16 times 1, and then add those 2 zeros on, and then I have 10 times 4, which gives me 40. Now I have 1 0 I can cross off here, 1 0 I can cross off here, but what that leaves me with is 160 divided by 4. So what I'm going to think about is, what is 16 divided by 4? I know that that equals 4, and then I have 1 0 left over, and that gives me my final answer of 40. So we're starting to get into bigger whole numbers now. So if you guessed we would start getting bigger whole numbers, you are correct. And then again, if you need to do the standard algorithm to solve this part, you can always do the standard algorithm to solve this part as well. So we're going to take a look at number 2b now. And for 2b, we have 1 68/100ths divided by 400ths. So now we have both numbers in the hundredths place. So I wonder what our answers will look like now. So if I have 1 68/100ths, again, I want to rewrite these as fractions. So I'm going to cover this up and think about, what does this number look like without the decimal? So it looks like 168 all over 100, because hundredths is my last place value. Then my division symbol, I'm not going to change my division symbol just yet. And then I'm left with 400ths, which I know I write just like this, 4 over 100ths. Now I can do my first few steps of division. So we're going to have 168 over 100 times 100 over 4, because we find the flip-flop of that. And now we can multiply. I'm going to do my multiplication down here so I can see it. So 168 times 100 would give me 16,800, because I have 168 times 1, and add on those 2 zeros, all over 400. Now, you might get a little nervous at this problem, but trust me, we can still do all of this math in our heads. So I have 2 zeros both on the top and bottom. So I'm going to cross off those two zeros. And what this leaves me with is 168 divided by 4. Now, what you'll notice is that I have a couple of factors in here that I can easily divide to get my final answer. So for example, I can do 16 divided by 4, and I know that that equals 4, but then I also have this 8 divided by 4 left over, and I know that that equals 2, and then that would be my final answer. And of course, you can always use that standard algorithm if you would like to help you solve these problems as well. So our answer for this one is 42. Now we are going to take a look at the U-try problem on the back, and you'll notice that the U-try problem is very similar to 2b. So what I want you to do is I want you to use the some of the work we did for 2b to help you out with this U-try problem. So you still have 1 68/100ths, which you can rewrite as a fraction just like this. but you are dividing it by 12 hundredths. So basically, the only parts that are really going to change in your problem is you'll write your problem like this instead. And then when you go to multiply, you should have 168 times 100 and then a 100 times 12. And then you'll have to figure out how everything gets multiplied from there. So 5th grade, good luck with this problem. And if you need any help, please let me know.